Hello everyone, in this video we are still talking about systems of linear equations, but now we're going to focus on the method of substitution. If you are looking for the method of graphing, go ahead and look at the top right hand corner of this video right now, and I'll post a link for that. Alright, so system of linear equations, the set of two or more linear equations in the same variables, which just means we have the same two variables in our equations, most likely x and y. If it's a word problem, you could have different letters in there, different variables. But both equations are going to have the same variables. A solution of a system of linear equations in two variables is an ordered pair that is a solution of each equation in the system. Okay, so we need to find whatever x is equal to and whatever number y is equal to, and that needs to be the same thing for both equations. Okay, so what we are doing is we are going to solve using the method of substitution. Okay, so three methods to solving a system. We have graphing, we have substitution, and we have elimination. This video we're going to focus on substitution, and here are our three steps over here on the side of the screen. Okay, so step number one, we want to make sure we solve one of the equations for one of the variables. So what that means is you want y equals or you want x equals, right? It doesn't really matter which one. We'll look at examples where we do one of each. Step two, we want to substitute the expression from step one into the other equation and solve for the other variable. So notice this says substitute the expression. Okay, so we're going to be substituting, for example, we might have y equals 4x plus 5. So y is equal to 4x plus 5. We're going to take 4x plus 5 and we're going to substitute it into the other equation for the y variable. Then once we find whatever x is equal to or whatever y is equal to, right, the number, then we're going to substitute that value from step two into one of the original equations, and we're going to solve for the missing variable. Okay. Once again, we have three solutions to a linear system. We have one solution, we have no solution, and we have infinitely many solutions. We will look at an example of each of those types of solutions. Okay. All right, so example number one, we have y equals negative x plus 3. We have 3y plus 5x equals negative 1. We want one of our equations to be solved. Well, this first equation is already solved right here, and it's solved for negative x plus 3. So y is equal to that. So now we can take this expression and we can plug it in right there for y in the other equation. And we're going to rewrite the equation like this. We're going to say 3, open parentheses, negative x plus 3, close the parentheses, plus 5x equals negative 1. Now we're going to solve for x, right? Notice what we've done. Now we don't have two variables, we just have one, so now we can solve for x. Distributive property, negative 3x plus 9 plus 5x equals negative 1. We can combine those like terms, negative 3x plus 5x, that's going to give us 2x plus 9 equals negative 1. We can subtract 9 from both sides, so now we have 2x equals negative 10. Divide by 2, and we get x equals negative 5. Okay, so that's one of our answers right there, right? X equals negative 5. Now what we can do is take this value and we're going to substitute it into, we can do it in either one of the two equations. However, I like to say take it back to the box, right? Where did you draw the box, right? Well, we did the box right here. That's going to be the easiest example that we can do, right? So I'm going to take negative 5 and I'm going to plug it right there in for x because I'm trying to solve for y. So y equals negative x plus 3, and we're going to plug in negative 5 right there for x. So we have y equals negative 5 plus 3, right? Be careful with that negative there. This is going to become positive 5, so we have y equals 8. Okay, so now we're going to say our solution is, remember it's an ordered pair, so our solution would be negative 5 comma 8. And that would be our final solution. So this, so this example is a one solution example. Okay. All right, so let's take a look at if we have maybe no solution or infinitely many solutions, how it's going to look different, right? How will we know that it's infinitely many or no solution? So example 2, solve the system by substitution. Okay, we have negative x plus 2y equals 7 and x minus 2y equals 7. So here I'm going to take, notice neither equation is solved, right? It's not solved for x, it's not solved for y. I'm going to take this second equation and I'm going to solve it for x, okay? So to do that, I'm just going to add 2y to both sides. So we get x equals 2y plus 7. So now I'm going to put a box around this because that is what x is equal to, right? So now I can refer back to that once I find my y variable. So now this was my second equation, right? So the equation I have not affected yet, I haven't changed yet, is this top equation. So I'm going to take this expression and I'm going to substitute it right there for x, okay? So I'm going to say negative, and then in parentheses, I'm going to put 2y plus 7, close the parentheses, plus 2y equals 7, okay? So now we're going to distribute this negative, and we get negative 2y minus 7 plus 2y equals positive 7. So now look what happens when we go to combine our y terms. Negative 2y plus 2y, those are going to cancel out, right? So that's going to be gone. So now we're left with negative 7 equals positive 7. Well, that is not true. Those numbers do not equal each other. So since that is a false statement, we can say there is no solution. Okay, so look what happened. Our variables canceled out, right? Variables canceled out, and we're just left with two constants, and they're not equal to each other, so it's no solution. So you might be able to guess what it's going to look like when it's infinitely many. We'll see that here on example 3. 4x plus 4y equals negative 8. Negative 2x minus 2y equals 4. Okay, so once again, we want to solve one of these equations for one of the variables. Doesn't really matter here. I'm going to go with the second equation, okay? And I'm going to solve it for y. So we'll start, and I'm going to add 2x to both sides. So now I have negative 2y equals 2x plus 4. And then I'm going to divide by negative 2, so I can solve for y. So y equals negative x minus 2, right? And I'm going to put my box around that because that is what y is equal to. So now I'm going to take this expression and I'm going to plug it in my other equation right there for y, because that's what y is equal to, right? And it's a system, so whatever y is in one equation, it's got to be the same thing in the other equation. So now we have 4x plus 4 times negative x minus 2, that's where we substituted that expression in, equals negative 8. So this is still 4x. Now we need to distribute this 4. So this is 4 times negative x, so it's going to become minus 4x or negative 4x. And then minus 8 equals negative 8. Once again, when we go to combine our like terms, they are opposites, so they cancel each other out. So that's gone. So now we're left with negative 8 equals negative 8. Well, that is true, right? That's the same number. And so now we can say there are infinitely many solutions. Okay, and that is how we solve systems of linear equations using the method of substitution.